Okay, and good morning to everyone, and I think I've got the mic on. So that was Los Lobos. What was the title of that, Ernie? Is This All There Is? And just a reminder that we are working in Chapter 7. We have work yesterday in dimensional analysis. We reviewed that, and we talked about when the next test is going to be. We talked about what's being done for the rest of this week. I'm skipping section 7-6, and so we're doing just the first three sections. And what I'm trying to have come up here in the computer and the server is being ridiculously slow. I'm trying to get the web page up so we can answer a question about, there, finally it happened. And the question, okay, now that's interesting. At this point, okay, we're in business. I'm going to look at Math 20 just for a moment because a question came up about the date on the exam. So let's look at that again. And let's take time to cut over now, if you would, Ernie, to the document cam. And looking down through, we are in week 12. And then as I come over to the right, you'll note that week 13, next week, will be the exam at the end of the week. And the sections 7.3, 7.4, 7.5 is what I'm covering this week. And we'll try to cover the sections on 8.1 and 8.2 before the exam. I'll probably be starting 8.1 on Friday, or Thursday, I should say. That's on percents. So the thing I suggested to you yesterday was spend some time on dimensional analysis from the work in the Orange book. And you might want to go back and review percents in the Orange book because that is the content that we're doing, and it's not any different than what we did before. So the questions from last night with dimensional analysis, working with the American system of doing measurement, are there questions? Okay, I need to know what page, if it's in the book or in terms of the computer. Okay, a computer question. And if you'll sort of get things together so we can look at that. Okay, Kim, let me go to the board and we'll see what we can do. Fire away.
I have 1.5 square yards.
1 1/2 square yards. And I want to go to square inches. Okay. Now, we're going to do it with dimensional analysis. So where am I going to start? With square inches. Okay, I'll agree with you there. Need to get a straight edge so I can make my fraction lines look a little bit neater.
I worked at a couple different ways.
Okay, well, let's see what we get. There are certainly more than one way of doing these problems. But I'm going to take square inches. And in terms of measurement, probably the one I know best. Lord, is that far downhill, or is that, again, just the keystoning, Ernie? Keystoning? Let's go to camera 1 then for a moment. Don't want to live with that. Let's see how level it looks just as we come to camera 1. My sense of being, out of curiosity, 20 and 20. That's interesting. That's still coming out, at least in terms of where I am there, 20 and 20. I'm within less than a quarter inch, and it still looks downhill. Okay. 144 square inches equals what? 1 square foot. Okay. Now, I have how many square feet in a square yard? 9 square feet in 1 square yard, because it's 3 by 3, correct? And I wrote feet in 1 yards. And then I have what? 3/2 square yards over 1, and that to me would be the most direct way of doing that. Well, it works that way because 3/2 is not going to change particularly. So to that extent, I look at what's crossing out, what Kim is saying, that she essentially ended up with this and had square inches. Okay, 2 into here, goes into here 72 times. And 3 times here is 216 times 9. So I have, what, a 54 and a 14 and a 19, so 1944. Does that agree? And again, I'm just looking at what I did there. Because I had 3 times 72 is 216, I preferred that multiplication, and then go to 9 times that, so 54 carry a 5, 14 carry a 1, so I have 1,944 square inches. Now, can you give me an idea of where the question is? If you set it up right,
I did set it up, but it told me I had the wrong answer. What I think I did, I think my multiplication maybe was wrong. When I multiplied on the 72 to 9 on the right.
yeah, I don't know.
We multiply all 3 of them, right?
Yeah, that's what I did. 3 times 72, I got 216 and 9. So if you ended up with a 1944 and you put square inches in, and then my guess is it's either notation or it is something weird, but you were setting it up correct, so let's leave it at that. Other questions on these sets of problems? This was dimensional analysis. I don't anticipate very many questions, but at the same time, accept that there may be. That's it? Okay, that went well, from my perspective. Okay, coming back to, now you're just going to have to zoom in, I know, Ernie, but section that's next is the same thing we've been doing, but we're going to do it with what? The metric system. And a question was asked a little bit earlier. Am I going to allow you to have something that would allow you to know the relationship of meters and centimeters and so on? And the answer is no. I want you to know these. So, procedures. And the question, of course, what do the prefixes mean? I guess that's probably the most difficult part here. And I was trying to note if we have anything that would help us here. And I guess probably the best source of the information that we have is down here at the bottom of page 537. So let's see what we can do here in terms of trying to get that so it's both bright and at the same time visible. The words. Now we're talking about a meter, and just as a comment, as we come off there for a moment, you've seen me use this straight edge so many times in terms of what we've done on the board. And this looks like, in terms of measurement, you called it a yardstick at times. And if I look at this in terms of what I see on it at the very end, and this is well worn at this point, it's a little more than 39 inches. And if I flip that over, you'll note that I have a 90, and each of these little measurements, in essence, is bringing me to what we would consider 1 meter long. And so if that's 90 of them, and then 91, 92, 93, all the way up to 99, and then 100, each of those is a centimeter. So if I think of putting my finger on here, the width of your finger, roughly speaking, is about a centimeter in terms of thickness, depending on your hand. Okay, and the distance, that smaller division, is what we call a millimeter. And it's about the thickness of a dime. So that gives you some idea. Now the question. If you look then at measuring things with meters, we had in our work in Math 10, we came across that golden mean, if you remember. And we've talked about it again here in Math 20, 1.618. And if you look at the relationship between a kilometer and a mile, then the mile is roughly that 1.618 kilometers. So again, we talked about the Fibonacci sequence. And I'm trying to get you to see the relationship between the American unit of measure, which we typically think of in terms of miles, and the metric system, which is in kilometers, km. And the KILO references 1,000. So if you think in those terms, 55 miles per hour was roughly 89 kilometers per hour. That was the Fibonacci sequence. Okay, so again, 55, 89, if you're doing 89 miles per hour on I-5 illegally, then you're going to be doing about 144 kilometers per hour. And we have that relationship that's fairly constant. So it gives you some idea maybe how they are related. For the most part, it's understanding what the prefixes mean. K for the 1,000 kilo. Centa is going to mean a 1/100. So if we say a centa, it's 1/100. And if you say milla, it's 1,000th, not a million. So 1,000th. And these numbers are down here as we take a look at it. The kilometer is used extensively in the United States, of course. And if we look at the next two, you will not find them used very often. A hectometer or hectometer is 100 meters. The decameter, DAM, is going to be 10 meters. And I, for the most part, thinking of all the years of travel and such, do not come across the hectometer and the decameter very much. In science, it's where we start seeing the others. And think of your place value system where you multiply by 10 or divide by 10. If you go to the meter and then divide by 10, you get a decimeter. Okay, that's what the dm stands for. And then you have the centimeter, where you divide it by 100. Okay, so in essence, if you take 100 of these, you get the meter, and that's what I just illustrated with the meter stick. And this is the one that we use so often in science, the millimeter. And it is an mm, and there are 1,000 of them in a meter. Now, as you think in terms of what we do in science, the milliliter and the centimeter, a cc. Now, I'm talking about volume measurements now. We had a millimeter and a milliliter. We start tying those together. So a milliliter would be 1/1000th of a liter. And a liter is about a quart. It's about 6% more than a quart. So if you have a milliliter, it is roughly what you put in a 1 cubic centimeter. So again, thinking of the centimeter on this scale I have here, and I think of then a cube, 1 centimeter on a side. Okay, so it looks roughly, otherwise if I think in terms of what I'm seeing in there, if I look between these two parts here, that's about a centimeter there, so you have a square inside those marks. And if you have that on each side, that's 1 cubic centimeter, and that holds 1 milliliter. And that is probably the most useful piece of information that you have in terms of the medical area and in terms of science and purchasing and so on. So what we saw with meters, we can go ahead and do in terms of volumes. Capacity, as it's called. And so we're going to come down to liter. And again, thinking of the liter as about a quart. Okay, it says slightly more than a quart. And as I say, about 1.05. So if I look at this, again, I can't remember very often seeing a kiloliter or a hectoliter or a decaliter. But you see liters, deciliters, and centiliters. I don't very often see centiliters, but you do see the milliliter, and notice that the milliliter and the cubic centimeter, cc or cm cubed, are going to be the same notation. So you have ml, cm to the third or cubic centimeter. Okay, so those are in terms of what we call volume. So you have distance and volume. And then we have what you would call weight for the most part, but technically in science it's not referred to as weight. It is considered a measure of mass. And that has to do with what happens in physics. And these are measurements, again, that I think you're fairly familiar with. And that is, as we come now back to the document cam, the kilogram. You don't find much discussion in science about the hectogram or the decagram, but you do have the gram and the milligram, and these two in between, the deci and centa. Don't see all that much in science, so it's the milligram, the gram, and the kilogram. Now notice the notations are the same though. A centigram would be 1/100th, a milligram would be 1/1000th. Now notice here that we have a liter of water has a mass of about, okay, as we come across here, I just lost where I was. The liter of water has a mass of 1 kilogram. Okay, so the idea of a liter and a kilogram with water is very much the relationship in the same sense that I said a cubic centimeter will hold 1 milliliter of water. And that's the way many of these things are thought of in terms of science. So volume, mass, and distance, I guess, if you want to think of it that way. So if you have a liter, a mass of 1 kilogram, and that's sort of the, shall we say, the relationship that exists. And trying to see if there's anything else that we can get from here that would help. Looking at page 542, and the last thing that's done here in 542 is to look at units of measurement in terms of area, where we talk about square meters, we talk about square centimeters, and so on. It's a little bit like Kim's question that we just did, where you take the square yards and go to square inches. If I run square meters and I want to go to square centimeters, you're going to use dimensional analysis. So let's look at there at the start with dimensional analysis, and I think as you use it, it may get easier, but it's going to be memorizing what some of the words mean. And that's, of course, one of the difficulties. But let's say we started with a square meter, and we wanted to go to how many squared centimeters you have. That's what I want to do. So Ernie, I'm going to, with camera 2 now, come over here on the right side as you face the board, and let's see what we would have. So I want to start with 1 square meter, and I'm going to take it to centimeters squared. So you might think of this meter squared to centimeters squared. And so here's where you're going to use dimensional analysis. And if you do this, I would suggest that you not try to force this through memory, just use your dimensional analysis. Tie things together, much as we did with square inches, going to square feet to square yards. So in this case, it's a little bit easier than some of the others would be. I want centimeters squared. Okay. Now, the question, if I think in terms of a meter, it's 100 centimeters on each side, correct? A meter is 100 centimeters. So this is going to be then 100 times 100 square centimeters is equal to what? 1 meter squared. And, of course, if I did something like this, 4 meters squared, and I wanted to get it in terms of square centimeters, I guess I should stay consistent here and use meters squared there. That would be the process. So I'm starting with 100 squared centimeters squared and 1 meter squared times 4 meters squared, and that should at the end give me how many square centimeters I have, because this is going to cancel. Now powers of 10 work very nicely here. So that's 10 to the second squared. So that's 10 to the fourth times 4 centimeters squared for my answer, which is going to be 40,000 centimeters squared. Fairly straightforward process. Now, where it gets a little more difficult is if I have something that is like a decameter or a decimeter, and then I have to see the relationship between them. Now, there are a couple things that we can do there. I've argued just a moment ago that if you think of place value, and I think of like a decimal point here for the moment, and I think of this being the ones place, and then we multiply by 10, and then we multiply by 10 again, we multiply by 10 again, the place values are exactly what we're talking about. Because if this becomes your 1 meter, then this becomes what? A deca. So this becomes a DEKA, decameter, and then this becomes the hecto, and then this becomes the kilo. Okay? Multiplying by tens. If we go the other way, otherwise this way I was multiplying by 10. If I go this way, we said you divide by 10. Now think of DE as decimal. That's the idea of a 10 of something. So in this case, we talk about a deca being here, because this is going to be 1 over 10. So this becomes the deca. And then we think of CENT for 100. And so that becomes the 1/100th, so centa. And then we go again dividing by 10, and we get 1 over 1,000. And we call that a milli. Now, in terms of what we're doing, it's just memorizing what you're doing as you carry across. Michael?
The term deca comes from, is that where they got decimal?
Yes, deca, meaning 10. And December was originally the 10th month, before the various Roman rulers decided to celebrate Julius for July and Augustus for August and made it 12. But December was originally your 10th month. Then they made it into 12, so it doesn't make as much sense as it used to. Okay? So to that extent, I hope that makes some sense to you as we come back. And I guess if I'm going to use the centa, I should put the double L there and not abbreviate that as badly. But the milli, the centa, the deca, these are the critical ones. Then coming across here, the deca, hecto, kilo, and you're there. Yes?
So whatever number that we have, depending on if it's centa or deca or whatever, you divide on the right, multiply on the
Yes, you're just like place values. You divide it by 10 each time to go this way, and you multiply by 10 each time to go this way. So 10 decas is a hecto. 10 hectos is a kilo. That place value chart seems to me the best place to see the relationships between these, rather than trying to memorize some acronym that's going to allow you, like my dear Aunt Sally, my poor dear Aunt Sally, or remember my poor dear Aunt Sally, for the order of operations. There is in the book, as we come back center, a way of, at least the author is asking you to consider as a way of doing this. And let's see if I can get to the phrase he uses. I came across it earlier. Was going to comment on it and then let it go. The relationship that is being talked about here is first presented to you on page 538, and it's the one we just talked about, where I start with meter and then go to the right, thinking of dividing by 10, your deca, your centa, going to the left, your deca, your hecto. If I bring that up a little bit higher, then you see exactly what I have on the board right now with the place value chart without reference to whether it's meters or liters or so on. So as I come off there, Do you recall, if any of you have read it through there, there's a phrase where he tries to help you remember which one is which, and I just saw it a little while ago, and now don't find the reference. Is it
540.
Is it 540?
Learning strategy.
Learning strategy on 540. Yes. Now, I don't know if this helped. King Hector's database decidedly centralized millions. Okay, so King Hector's database decidedly centralized millions as remembering kilo, hecto, deca, then your number, then your deci, centa, milla. If you like it, go for it. I've never heard that before, and I was an engineering major before I saw the light and became a mathematics major. But that meant, for your information, it means a full major in chemistry, a full major in engineering, a full major in mathematics simultaneously, along with your general college courses, and I never came across that phrase. So that's new to me. So King Hector's database decidedly centralized millions. Database. I made the change to a phone during the Christmas period of time. And of course, I'm getting a lot of calls for somebody who had the previous number. So every time they call, I say, will you please remove this person from your database? And Sarah reminded me that most people have no idea what I'm talking about when I say a database. So this particular acronym, I would suggest, is not time-honored in the sense of going back before computers, meaning before 1980. Okay. So the question, how are you going to remember these problems and how are we going to do it? That's what I'm going to look at as we try some problems. Before I do that, Sandra, your comment. Well, like 10 in deca. So when we say a decimal number system, it means we have base 10. So deca is 10. Now you have to decide, does that mean you're dividing by 10 or multiplying by 10? And that's where it's not clear. But if you understand that when we say a decimal, you are getting parts of 1. So a decimal means you have tenths and hundredths and thousands. So hopefully that'll help you remember which side you're on. On the right side, meaning a fraction of a whole. So if it ends in an I, it's a fraction of a whole. It's an I number. There's iPhones, iPods, and I numbers. And these are I numbers, centa, deca, milla. And the others are not. That's about the only way I can say it. Any other comment before we look at some of these conversions that are going to be asked? Now, there are a lot of little things that are done here. One that's not done, that's not talked about, and I just like to throw into the mix, is temperature. Okay, because we measure temperature in a metric, and what is the relationship there for temperature? I'm hoping that this works for you. Okay, we talk about centigrade, right? Or Celsius. Centigrade meaning centa in the hundreds, a hundredth of a degree. So 100 degrees Celsius or 100 degrees centigrade is what? You don't know that one. What is the temperature for boiling water Fahrenheit? A lot.
130.
No. 212 for boiling water. But it's 100 degrees Celsius for boiling water. And your standard temperature, when you take that temperature of your children and you go, oh my God. Okay, and Fahrenheit, what is it before you go, oh my God? 98.6 is considered average normal. And then when you get into the 100, 101, 102, you figure things are in trouble, right? You go outside on a summer day and it's 104. You don't know how hot it is. You just know you better have something to drink. And maybe something to protect you from the sun. Okay? Freezing in the usual Fahrenheit is what?
32.
No, I want freezing temperature in Fahrenheit. 32 degrees, right? So 32 to 212 is our range, 180 degree spread. Now, in Celsius or centigrade, you start at 0 and go to 100. 0 degree freezing, 100 boiling. So there's a ratio of about 1.8 if you're looking at a proportion. Now, my point in this, one of our difficulties as we look at these metric measurements is when somebody says they have a meter, I hope that you have in your head about a yard. When somebody says a liter, about a quart. Well, if somebody says that it is 70 degrees Fahrenheit outside, do you really know how warm or cold it is? You just know that at 70 degrees it's considered what? A rather moderate temperature, and you know not to bundle up, and you know you're probably not going to want to stay outside without at least a shirt on. You don't know the temperature. So I'm going to give you one on that we used to do in the Math 10 when we did the metric unit. I had a full unit in the metric comparisons and just found that it was one of those things that had to go when we tried to do the 2 books in a semester. Okay. The freezing fives. Okay. The freezing fives, the temperate teens. So the frosty fives, the temperate teens, the flaming 40s. Okay, I get this right in my head now. I'm going to have to go backwards. The flaming 40s, so by the way, 40 degrees you're above normal temperature. The 98.6 is about 38 something, close to 39. So when you hit 40, this is 100 degrees plus temperature for a child, and it's the flaming 40s if you're outside working and you want liquid refreshment. Okay, the thirsty 30s. So at 30s, you're talking about 90 degree temperatures and you're thirsty, but you're not burning up. Okay, so we have the thirsty 30s. I blew that. The temperate 20s, the tingling teens, and the frosty 5s. And that works amazingly well. Flaming 40s, thirsty 30s, okay, the temperate, so I have the thirsty 30s, temperate 20s, tingling teens, and frosty 5s. So if it's 17 degrees outside Celsius, tingling, you're going to be chilling in essence. So in the same way, if I tell you you have a kilometer, what's in your head? About 1.5 miles. If I think of a millimeter, it's about the thickness of a dime. Okay? So let's see what we've got in terms of the problems. Keep some of you focused and involved, lest you completely lose track of everything. There are 50 problems on 545. Okay? Here are the problems. You can see some of them that I've done. And the question, how are you going to do them in terms of dimensional analysis? Some of them can be done with the process that's being discussed in the text, which is multiplying by factors of 10 or dividing by factors of 10. But if you look at something like this, a liter to a centimeter. Okay, so I have centimeters, cubic centimeters, and liters. Let's try something like that first. Okay, so this is 25. So I'm going to take a liter to a cubic centimeter. Question before we do that.
Well, liters is liquid, right?
Ah, but remember, now what you're going to say is a liter is a liquid and a centimeter is a measure of distance. But we said 1 cubic centimeter holds 1 milliliter, and therefore a milliliter and a cc are used interchangeably. They're both volumes. Yes. So let's go back to the problem. Here's what I would expect to see, and I'm not convinced that it's necessarily the best way of doing this. I'm going to be in trouble here with this. Okay. Yeah, I know what it is. And Ernie, I had talked with Debbie about that, and we are on a broadcast right now. Do you know what we're supposed to do based on, we were assured that this would not be happening because of the broadcast. Okay, I'm going to go to the side. Let's bring that over to the side. Just sit there and enjoy yourself. Now, this is a program drill. Okay, coming over to here. Okay, here goes. Let's come back. I need what? At this point, I'm on number 25, and I'm going to cubic centimeters. And I start with what? 0.08 liters. So I have 0.08 liters, and I'm going to cubic centimeters. So as we look at this, 1 cc is what? 1 milliliter. So 1 cc is 1 milliliter. Now 1,000 milliliters is 1 liter. And then I multiply by 0.08 liters over 1. And notice the milliliters cancel, okay, the liters cancel, and I'm left with cc's. And that is the process that we're going to go through. We're going to have to follow. Okay, well just, if you'll...
That way, go between the tennis courts and classroom annex.
Okay, I'm going to close down here. Okay, so at this point, Ernie, we have had an interruption here. Brian, I regret to tell you, why don't we go to music in the slide? This is an interruption. Just quietly exit, please, while I try to close down. Okay, and go that out there. Now, we're going to close down with music temporarily. And we'll leave